So my dear students, hope you all are okay in this hard situation. You are taking care of yourself and your family as well. Still we have to start our online classes, and I will start with the remaining chapter, alkaloids, with its little bit introduction. You know that alkaloids are a plant origin and are very much useful in medicine, medicinal chemistry, medical purpose or treatment of various diseases because of its highly physiological activity and its specific rotation as levorotatory, though in some cases it is dextrorotatory also. So by PowerPoint presentation, I will show you one by one slide and we will discuss little bit. So because of that, it will little bit helpful for you so that you can visualize it more clearly. Yes, it is right now. Yes, so we will start with alkaloids and its introductory. So it is an introductory chapter of alkaloids. So first of all, you know that alkaloid, the name actually it means alkali-like and was given to all organic bases isolated from plants. It has wide variety of compounds. That means alkali-like organic bases, but it has wide variety of compounds. These two sentences indicate. Further, naturally occurring organic bases which contain a pyridine ring. This came as including words pyridine ring. So alkali-like organic bases and pyridine ring. Still, it is limited number of compounds. Later, the scientist Ladenburg stated that natural plant compounds having a basic character and containing at least one nitrogen in a heterocyclic ring. So, the definition given by Ladenburg was included that heterocyclic ring should contain at least one nitrogen, natural plant and having a basic character. Still, it excludes any synthetic compounds and any compounds from animal sources. So, by this all we can conclude that it is actually alkali-like any organic bases which are isolated from plants. It has at least one nitrogen in the heterocyclic ring. It is of very poisonous. It has medicinal point of view. It is very useful. It has very complex structure. It is physiological very much active and obviously from plant origin. For example, purine. Purine is not classified as alkaloids because few of the purine it obtained from the animal sources. Regarding occurrence, the quantity of alkaloids or amount of alkaloid content varies with the species, that is from which plant we are getting the alkaloid. Then age of the plant, season and climate. So the two important parts is season and climate. So occurrence, it will vary with the species, age of plant, season on and climate of the particular area. And as salt of acids, like which acids are there? So we can get it as salts of the acids of malic, citric, oxalic, succinic or in some cases tannic acids. And the distribution in plant, that means we cannot get the alkaloids from all parts of a plant. So for example, the dhutura, where we can get the alkaloids from all of these parts. So it is very useful. Every part we can get the alkaloid from dhutura. But cinchona, we can get alkaloid from its barks. Nux vomica, we can get the alkaloid from seeds. Roots are useful for aconite. Fruits for black pepper. We already having it regularly. Tobacco. The leaves contain the alkaloid. In case of opium, the latex contains the alkaloid. So various other plants are over there in the world from where the alkaloids we can get. Function in plants. How does it work? They may act as protective measure against insect herbivores because it has a very bitter taste and also it is toxic in nature. It is also a source of nitrogen where the nitrogen deficiency is there. It acts as growth regulators in certain metabolic system. Now physiological action. Why is it so useful for medicinal chemistry? So many medicines are prepared from the alkaloids only because of its physiological activity. Highly physiological active in nature, and also it is levorotatory in most of the cases, but few cases are there where it is dextrorotatory. So specific rotation is there, as we know that it should have the specific rotation for all medicines because only one enantiomer is very much active for the medicine. To prepare the medicine, we need to know the specific rotation. So there are some examples where we can see the usefulness. Where do we use the alkaloids? So for morphine, we use it an analgesic, depressant action. Reserpine, we use it for the treatment of snake bite, epilepsy, insanity, tranquilizer. Quinine, we all know that we use it for the treatment of malaria. Nicotine, we use it in case of insecticides and in the treatment of Parkinson and Alzheimer. Cocaine, we use it as anesthetic. Hygrine for laxative, diuretic, hypnotic and sedative. So these are few cases where we use the alkaloids as the medicines. Now the isolation or extraction. So how do we isolate it? How do we extract the alkaloids? So in the pure state, the alkaloids, we cannot get it in the pure form because it is extremely laborious. But in the powdered material, so the material is getting powdered and it is mixed with alkali, then extracted in Soxhlet extractor with the organic solvents like chloroform, or it may be with, in some cases, water or alcohol in dilute HCl or acid, any acid. So extract contains alkaloidal salts. So by that way, from the Soxhlet extractor, we can get the alkaloid salts, which are free alkaloids released by alkali. But the released alkaloids which are getting up the extraction is actually crude mixture. So we need to separate them, and it is separated by using fractional crystallization method, maybe from precipitation method, chromatography, distribution or any other available methods. So in summary, the powder is treated with alkalis to liberate the free bases that can then be extracted with water, which is immersible organic solvents. The powdered material is extracted with water or aqueous alcohol containing dilute acid. Alkaloids are extracted as their salts together with accompanying soluble impurities. The powder is extracted with water soluble organic solvents such as methanol, ethanol, which are good solvents for both salts and free bases. So not all the alkaloids and their salts are soluble in any alcohol, soluble in water, or they vary compound to compound. So the salts and pure alkaloids are soluble in different solvents. The physical properties. Most of the alkaloids are crystalline solids, but few of the alkaloids are amorphous solids. Example given emptying. Some of the alkaloids are liquids in nature and that are either volatile or it may be in some cases non-volatile. The majority of the alkaloids are colorless, but some are colored like berberine are yellow and xanthine is orange. They have bitter taste. They are optically active. Already we told that most of the cases is levorotatory, but few are dextrorotatory. Some inactive alkaloids are also there like papaverine. Solubility. Both alkaloidal bases and their salts are soluble in alcohol. So organic solvents, they are soluble in this organic solvent alcohol. Generally the bases are soluble in organic solvents and insoluble in water. In most of the cases the alkaloidal bases are insoluble in water but soluble in organic solvents. The bases soluble in water, which are they? Caffeine, ephedrine, codeine or caffeine. Sorry, repeating is there. Bases which are insoluble or sparingly soluble in certain organic solvents. These are morphine in ether. Classification. How do we classify the alkaloids? The bait is based on the biogenetic pathway, that is in which way they are generated, in which pathway we can get the alkaloids. Then botanical sources, from which plants we are getting the alkaloids. Types of amines, primary, secondary, tertiary alkaloids. So the alkaloids is containing primary, tertiary or secondary amine. Basic chemical skeleton. So the carbonyl skeleton is which type, is of which type. By that way we can classify the alkaloids. Like phenyl alkyl amine. If it is present over there in pyridine system and bipyridine system, example given nicotine, lobeline. If it is quinoline, then quinine and quinidine containing papaverine, emetine, etc. If it is indole, then in class of imidazole, it is pilocarpine. These are few examples over there. Some chemical method, chemical test by which we can identify the alkaloids. So first of all was Mayer's test, then Dragendorf reagent test, Wagner's test, Hagel's test, ammonia Rinker's test. So these are the positive tests. By this positive result we can identify the alkaloids as well. General structural features. This is actually the important topic for today. How can we identify or feature the structure? So first of all we need to module some physical and chemical methods. By step we can get the general structure. So first of one is qualitative analysis. So by qualitative analysis we can get the number of carbon, number of hydrogen, number of nitrogen, and if there is oxygen. So we can get the compound containing carbon, hydrogen, nitrogen, oxygen. So which type of compounds, which type of atoms are including in that compound we can get by qualitative analysis. Regarding quantitative analysis, we can get the empirical formula. Now, by determining the molecular weight, we can also get the molecular formula. So, few informations are already with you. Which atoms are including over there? The empirical formula. By determining the molecular weight, also the molecular formula you are getting. And also the specific rotation is also determined. Next, the number of double bond rings present in an alkaloids are also determined. So these are all physical properties. By physical methods we can get the little bit information over there. Now the functional group analysis. So by the structure determination involve the various chemical and physical methods. By physical methods we can get those information, qualitative, quantitative, and lastly the molecular formula is obtained. Now regarding functional group analysis, if there is any unsaturation we can get the result by bromine test. We do it in our lab experiment. Then degree of unsaturation, that means how much unsaturation, how many double bond or triple bond are linked over there. By catalytic hydrogenation, that means if two hydrogens are linked over there, then one double bond is there. Like that we can get the degree of unsaturation by catalytic hydrogenation. Functional nature of oxygen. If there is oxygen linked in the alkaloid, then what are the groups available? First of all, it may be phenolic or alcoholic OH. It may be methoxy, acetoxy, benzoxyl, carboxylic, carboxylate, keto or lactone. So one by one we can get the information by different chemical method, by different chemical lab experiments. So first of all, it is hydroxyl group. So it can be determined by the action of acetic anhydride or acetyl chloride, the formation of benzoate on treatment with benzoyl chloride, benzoate on treatment with benzoyl chloride in the presence of sodium hydroxide. It's a test by which we can get the information it is hydroxyl group of which one? Phenolic OH or alcoholic OH. If primary amines are present in an alcohol, also give this test. So by that information we can take the information about phenolic and alcoholic OH. So one more thing that you have done the experiment of FeCl3 test. By FeCl3 color change method we also get the information about phenolic OH. Our next case is carboxylic acid group. Solubility of an alkaloid in aqueous sodium carbonate or ammonia reveals the presence of carboxylic group. So solubility in sodium carbonate or ammonia, which is the result of the carboxylic acid group experiment. The formation of ester on treatment with an alcohol, which reveals the presence of carboxylic acid group. So we already do, usually it is very useful method in our lab experiment where we form the esterification test. Then the number of carboxylic groups may be determined by volumetrically or gravimetrically. In volumetrical method, the titration is over there. We do the titration against barium hydroxide solution using the indicator phenolphthalein, and gravimetrical analysis by silver salt method. So by that way we can know the number of carboxylic acid group linked over the alkaloids. Or next is the oxo group. This is actually ascertained by the reaction of an alkaloid with hydroxyl amine. So formation of an oxime, semicarbazone and phenyl hydrazone can be the result of the presence of oxo group. So semicarbazide or phenyl hydrazine, when the corresponding oxime, semicarbazone or phenyl hydrazone are formed. So this distinction between aldehyde and ketone is done by oxidation or reduction and also by NMR, IR and UV techniques. So oxo groups can be determined by the oxime test or phenyl hydroxylamine test, semicarbazine test. So these are the way we can know the information about presence of oxo group. Now methoxy group. It is actually done by Jessel's method. So presence of this group and their numbers is determined by the Jessel's method, where the methoxy group is present in alkaloids which is treated with HI, hydriodic acid, at 126 degrees centigrade, which is yielding the methyl iodide, which is treated further with silver nitrate to perform the silver iodide precipitate. So silver iodide precipitation is occurring at last step. From the weight of the silver iodide, the number of methoxy group is calculated. So you can see this example, this equation where 4 mole CH3I, 4 moles AgNO3, 4 mole AgI and 4 mole CH3NO3. So if AgI is of 4 mole, the CH3I will be also 4 mole. So indirectly from the weight of the silver iodide we can get the information about the presence of methyl iodide, right? Next, for example, papaverine, when treated with hydrogen iodide, consumes 4 moles of hydrogen iodide, 4HI, so that producing 4 moles of silver iodide indicates presence of 4 moles of CH3I. So we can get the information about the presence of methoxy group. How many methoxy groups are attached over there? So 4 CH3I comes from 4 OCH3, 4 methoxy groups, right? Next, ester, amide, lactone and lactam group, which is estimated by observing the products of their alkali acid hydrolysis. So, alkali hydrolysis, we can get the information about the presence of amide, lactone or lactam and esters. So, here two examples I have given over there. Nature of nitrogen. As a part of heterocyclic system, therefore it must be either secondary, tertiary or primary, whatever it may be. The general reaction of the alkaloid with acetic anhydride, methyl iodide and nitrous acid. So these are used to identify the amines. What type of nitrogen is linked over there? If the alkaloid reacts with 1 mole of methyl iodide and we can get the N-methyl derivative, that means it is secondary nitrogen atom present over there, right? If it reacts with methyl iodide to generate the crystalline quaternary salt, this indicates that the nitrogen is tertiary in nature. Next one is our distillation method. Distillation is actually done in presence of KOH, and by that way we can get the number of alkyl groups attached to nitrogen, right? So nature and number of alkyl groups we can get by the distillation of alkaloids. Methylamine, dimethylamine or trimethylamine attachment of 1, 2 or 3 methyl groups to nitrogen. So if it is methylamine or dimethyl or tri, then that means the nitrogen have attachment methyl group is 1, 2 or 3. If it is ammonia generated, then that means the amino group is present, so with the alkaloids. Degradation of alkaloids. The reaction used in degradation of alkaloids are as follows. First one is Hofmann exhaustive methylation method, MDS degradation method, reductive degradation and zinc dust distillation method, alkali fusion, oxidation and dehydrogenation. So these are the few ways that in this way we can degrade the alkaloids and we can get the information about the physical characteristics and features, structure of the alkaloids. So first of all is Hofmann exhaustive methylation method. The principle of this method is that where the heterocyclic ring are open. Heterocyclic ring are open with the elimination of the nitrogen, and by that way the carbon skeleton we can get the information about that. Actually, heterocyclic ring is opened with the elimination of nitrogen in this Hofmann exhaustive methylation method. So here is the example, the mechanism and the detailed mechanism I am showing over here. See, it is pyridine. By the reaction with methyl iodide, we can get this product where 2 methyl groups are attached over here, attached with nitrogen. So heterocyclic ring is opened with the elimination of nitrogen. Here heterocyclic ring is opened with the elimination of this NCH3 whole twice. Here it is broken. The N bond C bond is broken over here. It is very important process in alkaloid chemistry. First, to hydrogenate the ring. First of all, we will hydrogenate the ring so that from pyridine this product we can get. So all the double bonds is hydrogenated and the unsaturated compound is converted to saturated compound. Then the conversion of the compound to quaternary methyl ammonium iodide salts over there, and lastly quaternary ammonium hydroxides, which is again heated and by the elimination of H2O with the help of beta hydrogen, alpha position and beta position. So beta position hydrogen, elimination of beta position hydrogen with respect to nitrogen. This process is repeated unless complete removal of nitrogen is occurring and leaving an unsaturated hydrocarbon which isomerizes to a conjugated diene, right? So this is actually the Hofmann exhaustive methylation method, and this is the complete mechanism. Next is our MJ degradation. MJ quaternary ammonium halide is reduced with sodium amalgam in aqueous ethanol or sodium in liquid ammonia. So if the alkaloid does not contain a beta hydrogen, then only the MJ degradation occurs, because if beta hydrogen is absent, then Hofmann's exhaustive methylation does not occur. This is the MJ degradation method, where the final step involves reductive cleavage of quaternary ammonium salts either with sodium amalgam or sodium in liquid ammonia or by catalytic hydrogenation. So alkaloids which do not respond in Hofmann exhaustive methylation, the MJ degradation there occur. So here is the mechanism. So from isoquinoline, again with the using of sodium in ethanol, this two system is hydrogenated, and after application of methyl iodide in presence of silver hydroxide, this product, and again beta hydrogen over there, so alpha beta. Next, the breaking of carbon nitrogen bond. Here no beta hydrogen is over there. So afterwards, with the help of sodium amalgam in presence of ethanol, with the elimination of trimethylamine, this unsaturated product we can get. And the feature of the structure, we can get the information about this nature. Next is our gene dust distillation, which produces simple fragments from which can draw the conclusion about the carbon framework, that means carbon skeleton. Which type of skeleton is there in the alkaloid molecule? Gene dust also brings about dehydrogenation or removal of oxygen if present. Next is our alkali fusion. It is a drastic method where the alkali with the help of KOH yield some very simple fragments. Like papaverine on fusion with alkali generates isoquinoline derivative, which indicates that papaverine must contain the isoquinoline nucleus, right? So as it is with alkali fusion generating the isoquinoline, so it should have in the skeleton structure the presence of isoquinoline. Oxidation. This method gives useful information about the structure of alkaloids by varying the strength of oxidizing agent. So by changing the strength of oxidizing agent, we can get information about the oxidation products, and it is possible to obtain a variety of oxidation products. In order to carry out mild oxidation, hydrogen peroxide, iodine in ethanolic solution or alkaline potassium ferricyanide are usually used. So these are the oxidizing agents which we will be using, right? In order to carry out moderate oxidation, so for moderate, little bit mild but not so much exhaust, it is the alkaline potassium permanganate or chromium trioxide in acetic acid, right? So mild oxidizing agent, powerful oxidizing agent. So by varying the nature of the oxidizing agent, we can get a variety of oxidation products. Next is our dehydrogenation. When an alkaloid is distilled with a catalyst like sulfur, selenium or palladium, dehydrogenation takes place to form relatively simple and easy recognizable products which provide a clue to the gross skeleton of the alkaloid. So if the alkaloid systems undergoes dehydrogenation with the help of sulfur, selenium or palladium, then from the dehydrogenated product we can get the information about the skeleton structure of the alkaloids. So these are a few characteristics, few ways by which we can get information about the feature or structure of the alkaloid system. So this class is finished for today. Thank you.